know. And by the way, if you're watching the animations, the company is supposed to say ground cover. It stopped at ground for some reason, and I'm so sorry, Aviv. I don't know why that happened. But he is going to be one of our guests on the show. Anyways, I got ahead of myself. I noticed that the title didn't continue, so I was like, oh no. Anyways, welcome to our second episode of the year of OTel in Practice. I am Reese.
And I am Adriana, coming to you from Toronto, Canada. And where are you coming from, Reese?
Portland, Oregon. So actually, I'm in Vancouver, Washington, but people confuse that with Vancouver, BC. And so I just say Portland, Oregon. We're literally like 10 minutes, by bridge. But yeah, I have to like disappoint people when they're like, oh, it's so beautiful. I'm like, oh, no.
Not that Vancouver.
Vancouver, Washington State. But yeah, we have a pretty fun episode lined up for you today. I see we've got some people from another West Coaster. We've got someone from Sweden.
Yes. Henrik's broadcasting or producing from Sweden today. Yes. Oh, someone from Montreal.
Oh,
yay, Canada.
Where is Montreal in relation to Toronto?
So it's about a 1 hour plane ride. Slash like I want to say it's northeast of us. Yeah. And it's about, I would say, like probably like a 6-ish hour car ride.
Oh, that's not
from Toronto.
Okay. Yeah, that's about Portland to Vancouver, BC, actually. 6 hours.
There you go. Drive. Vancouver to Vancouver.
Okay, so yeah, we are going to be
Glasgow. Sorry.
Oh, wow. We have a lot of I almost said Europeans, but I think I was lumping in Montreal.
I mean, Montreal's got like a very Euro vibe for parts of it, for sure.
Thank you for backing me up on that one. Yes. Oh, and Switzerland. Okay. Another West Coaster. Okay, so we're going to be learning about eBPF today. And I don't know about y'all, but it's something that I've been meaning to learn more about. So I'm very excited about our session today, because that's what Aviv Zohari is going to be talking about from groundcover, by the way, if you saw that title slide. But anyways, yeah, Adriana, would you like to introduce our guest?
Yes. Oh, and we should also mention about the format. So after Aviv presents, then we will have Q&A, which is going to be hosted by Nicola, who has graciously agreed to host the Q&A for us, because he is involved with the eBPF side of things in OTel. So we've got two eBPF gurus here today.
Hi, everyone.
Hey, Aviv, what's up?
Doing well. How are you, Reese? How are you, Adriana?
Hi, Aviv.
Where are you
welcome. Thanks for coming on. We can't wait to hear you present.
Thank you. Joining from Tel Aviv.
Oh.
Awesome. So we've got quite the sprinkling of people from across the world. I love it.
Got Aviv from Tel Aviv.
Yeah, I've never heard that one before. So.
Sorry,
I'm joking.
You can never escape. But yeah, if you would like to...
Oh, sorry, go ahead.
Oh, no, go ahead. I was just going to say, if you would like to, introduce yourself, and then we can get started with your presentation.
Yeah, happy to. So I'm Aviv from Tel Aviv. So I'm a field CTO in ground or ground cover. You could do either, I guess. No, I'm joking, in ground cover. And been doing quite a lot of things in the observability field over the last couple of years. Turns out I'm a big fan of observability. It's not something that I've been doing for that long, I guess, compared to other people in the space. But being like a developer, being someone that's worked with these tools for a while, it's amazing how interesting it is to be in this space and work with it and see how it develops. And it's changed so much over the last few years. It's continued to change drastically. Yeah, and today's topic is super close to me, both because I've been involved in the eBPF parts of groundcover for a long time now, and also because of recent developments. Nicole being a major part in this as well, but it's something that it's reached its hype right now, I think, in OTel and in the open source world as well. So it's super interesting, and yeah, let's get into it.
Ooh, I'm excited. Thank you. Take it away.
Okay. So hi, everyone. Thank you for joining, and thank you for the warm introduction. So we're going to be talking about how eBPF tracing meets OTel tracing, or OTel SDK tracing, to be more correct, and kind of the journey that I think I went through personally, or I think a lot of people I know went to kind of realize that you kind of need both. You need the powers of eBPF, which we'll get into in just a moment, but you're also gonna need the OTel SDKs. And it's about figuring out when to use each one of these and what can you get from both of them. So I spoke a little bit about myself. I didn't mention I was also a very big video game nerd. So happy to discuss about practically any game with anyone if you're up to it. It could be on the Q&A as well. No, I'm joking, but can do it whenever anyone's like. And today we're going to be talking about, well, how do you do tracing? How do you actually do tracing in real life environments? What is tracing and when you should use it? And I think why is it a bit more tricky and sometimes not the first thing you do, but at the same time, you want to do it. It's why is it difficult, and how eBPF solves it, or at least pushes it forward to a point where it's becoming more of a commodity in the best way possible. And I'd like to start by talking about the 3 pillars. Now, anyone who's done anything in observability for a while knows this. Basically, this is what everyone uses. You have logs, you have traces and metrics, and everyone knows you kind of need those. It's something that when you're trying to do observability, you read about it, and each one of those has their own purpose, and it's cool. But I think that the term, the 3 pillars, and the way that I've kind of put them here on screen, well, it insinuates that they are equal and that you should be using all 3 of them. And this is what you'd expect to find, maybe, right? When you look at how stacks look and what observability people have, you should have all the 3 pillars, because otherwise it doesn't make sense. But I think in reality, this is from my personal experience working with a lot of people in the space over the last few years, usually what you have, first of all, is an abundance of logs. You have way too many logs. You don't need all of those logs, but you still have them. And I think the reason for this is that logs are, first of all, that's the first thing you learn when you code, right? I mean, hello world is practically logging something. So everyone knows how to do it. It's very intuitive. The second part is it's very elastic. So you could log everything, right? You could log a debug message, which is cool. You could also debug, you could print out a full HTTP request, or you could count something in logs. And basically, you could do everything with logs. The problem is that trying to do everything with this, the 1 pillar, right, creates a lot of noise. It creates a lot of pressure on your backends, on the systems. And it's not really what you want to use for a lot of use cases. So this is why we also see metrics more often than not. So metrics would be a bunch of things. Metrics could be core business. So basically count every time that someone enters your website, right? And you increment a counter and you send those counters, and then you know the trends. It could be infrastructure, which is a whole different thing. And a lot of integrations also come as metrics. It's one of those things where you integrate with your cloud provider, you're going to get metrics. You integrate with databases, you're going to get metrics, right? So again, I think going from logs to metrics. Logs is very intuitive. Everyone uses it. You're going to find it everywhere. Metrics, you kind of need to understand how to use it and when to use it. But I think I see it more often than not. And then they have traces. Now, it's not about being harder necessarily, but it's about where do you start and how do you get traces, right? How do you make sure that you're covered, and where do you need them? Do you need them everywhere? Do you need them only for specific use cases? Who's responsible for it, right? Is this a developer? Sure, but does it mean that every team needs to do tracing? Because if only one team does tracing, is that helpful? Because we want distributed traces, right? So it kind of gets to this point where I feel a lot of teams don't start with traces. They kind of say, we'll log everything and we'll get to it later, and then they end up never doing it. And by the time they realize they need traces, it's difficult to implement them. And this is kind of, I think, where groundcover as a company came like a few years ago, started using eBPF for tracing, because this is what we felt was the issue with a lot of teams, right? Like I've been on teams where this was the issue as well. And I think the key part to understanding why eBPF is so cool for tracing is to figure out what we had before or what we still have, but what else do we have? So manual instrumentation, right? Basically adding code to push traces or push events or push anything into whatever backend you're using. This is the first method to do it, right? So you have to write custom code, you have all the different SDKs, and it's difficult to maintain. And it's always the last thing that you get to. You always need to push another feature. You always need to make sure that some bug is fixed. And then maybe if you have time, you can add some span somewhere. So it's difficult. It really is difficult to do it. And then we got into automatic instrumentation, right? So a lot of the OTel SDKs out there do automatic instrumentation. You just plug in some Java agent or some Python binary or some Node, whatever, right? And you automatically instrument every HTTP call, every SQL call. That's amazing. But there's a few hurdles with this as well. First of all, it doesn't work for every framework. So you can't do it with some of the modern languages like Golang, right? And the second problem is that it ends up adding significant overhead. And this is something that is often overlooked or maybe difficult to kind of measure even. But if you're using, for example, a Java agent to instrument your code, then you're doing quite a lot of overhead to your application, which is already running in production to be as optimized as possible. So there are some considerations here that, again, might work, might not, depending on your use case. And then we got the eBPF. The B is absolutely, this is one of the best logos I've ever seen for technology before. Why is eBPF so good for us, or so good for this use case of tracing? So eBPF is, like we've heard in the intro, I think it's a buzzword again, like crazy match with the B. That's been around for a couple of years, and it's been used for different things. And I think at this point, a lot of people kind of know something about it. So I'll just quickly explain it in 30 seconds. It's a Linux kernel technology. It's also in Windows recently, that lets us peek into every event in the system from the kernel level. So you could look into everything the operating system is doing. And this is different than existing technologies like kernel objects in the sense that it lets you do it safely. So the operating system guarantees that even though you have amazing access into everything that's happening, you can't hurt the system. And this opened up the door to do a bunch of things. So for example, if we're able to track every network call on the system, so every time one of your applications is accessing some HTTP request, it's doing something to get whatever, this ends up going through the kernel. The kernel has to transmit packets over the network. So you can inspect the packets, and you can figure out that there was an HTTP call. Same for every other type of protocol, essentially, if you know how to dissect it and how to figure out this is the underlying operation that's happening. Now, at the same time, because the operating system is responsible for running the processes be it containers, be it just processes without any containerization, doesn't matter. End of the day, when you track this call, you also know who's doing this call. And that gives you the ability to associate an HTTP call, for example, with the underlying container. So it lets us essentially see what is happening within every one of our applications without from the outside, right? So as a sideband, essentially without any of the developers or any of the technical teams, the SRE, the DevOps, doesn't really matter. No one has to do anything in the code, in the application, in the instrumentation. There is no instrumentation. You figure all of this out just by observing the system. And I always like to say that if we have logs and we have metrics and even traces, even manual traces, these are things that I would say people, at this point, it's probably people and LLMs, but that the developer or the writer of the code decided is important and you want to capture and you want to log. And eBPF gives us kind of a different approach into it. It gives us the physics, in a sense. This is what's happening. This is the behavior of your programs, whether you know it or not. So you get it with no instrumentation. It starts running within a few minutes. It covers everything in your stack, every third-party service, even things that you can't even instrument, right? And it's also doing all of that with very minimal overhead. That's also very cool. It has to do with how the technology works behind the scenes. Basically, it's incredible. So we're done, right? I mean, eBPF basically gives us everything. And to be honest, for a while, from my personal perspective, when I started working on this technology, I was convinced it's true. That basically this is all you need. And I think after a few years now of working with it, I think it depends. It depends on what you're trying to achieve. And there's probably always going to be use cases that still require the manual touches. But that's fine, because once you figure that out, once you figure out that you have both tools, then you can just make it work for what works for you. So what does that mean? Well, with eBPF, we get 100% coverage. We get a safety net that we know that once we've deployed this tracing technology, nothing is going to happen without us knowing about it. No HTTP code is going to fail, or no SQL query is going to be too long. But what about other stuff? What about business logic? For example, if you want to monitor something that's happening inside the process, you've made a decision based on something and you want to note that. So you could log it, but that's not gonna, it's gonna correlate with your trace maybe, but you want to have a span for it. You want to have a decision, like a tree, a process that you could visualize. This is traces, right? Same for A/B testing, for example. You want to note that I've went this way and not that way, or I've done this and not that for a reason. And you can't do this with eBPF alone, because eBPF, the power of it is it doesn't need any manual, inter-inspection of the process. But that's also the disadvantage. It's not something you can configure to catch flows in your code that no one knows about beforehand. So it has those limitations. And LLM observability, I'm going to talk about more in depth in a few minutes. It's also a very interesting use case. So what should we do? What should we do? Well, the answer is layering, which is actually the most intuitive one, but I think it's not either one of them. It's a better together story, 100%. You want to use eBPF, this magic technology, for basically, well, for everything, to cover everything, right? So be it new applications that have no instrumentation. So you didn't get to instrument your code, but you still want to see what's happening. eBPF is going to have you covered. If you want to look at third-party services, same thing, right? You cannot instrument what you cannot control. So maybe they have OTel, maybe they don't. Either way, you're going to be able to kind of view that. You can get service level metrics. So essentially, golden signals, right? For each one of your services, measuring the latencies, the request rates, the error rates, all of that, no changes. And this kind of gives you the reassurance that you can deploy something and it's not going to break without you realizing it. But at the same time, you should definitely still be using OTel SDKs where you need them. And you will need them for your most critical flows, where you need that extra layer of visibility, where you want to make sure that you can see everything that's happening with this core business flow. You want it when you need to kind of follow a complex logic, where you want to, again, say, I've done this, and then I've done that, and this is why. You want it for distributed tracing, and here I'm going to say that the OBI project, the eBPF OpenTelemetry project, that one of its core developers is going to be joining me very shortly, is doing distributed tracing for eBPF-based traces, partially. And I've seen the roadmap for this year. It's going to get expanded. But this is one of the trickier part of eBPF tracing. And we could talk about it more if anyone's interested in Q&A, but know that doing this correlation of different calls between services, and more specifically in services, with eBPF is difficult. Possible, in progress, works in multiple frameworks. Yeah. And last one is LLM observability. And this will be the last thing I'll touch before we go into Q&A. So there's two things that are worth mentioning. First one, as you all know, we're in a new age where things are rapidly changing, and observability is going to have to follow suit. And it's kind of shifting rapidly over the last few months, few year. It's going to continue doing that. And there's two interesting things to talk about. So the first one is observability in the age of coding agents, right? So there's so much more code being generated than ever. Everyone knows that. It's scary, it's exciting, it's everything together. And with more code, we get more things that we need to track. Now, coding agents write code very well. I think at this point, everyone already agrees on that. They're not doing instrumentation as well so far. And I've put this link to and benchmark by Kesma, which are a really interesting team that doing some really cool stuff. They've posted this benchmark about how well are LLM agents instrumenting code. And I've seen it myself as well. It's not that it doesn't generate traces. It generates traces that are not what you would probably do if you were the one doing it. It's not exactly what you mean, essentially. And I think the more interesting part is that even if the traces are perfect, let's say that everything is perfect, you get automatic instrumentation for everything, it all makes sense. There is no engineer anymore that can actually understand the instrumentation. So we're going to start trusting LLM to give us tracing that makes sense, because we're just not going to write code anymore, right? But at the same time, when you're going to try and troubleshoot that, then you're going to want to have a baseline that you understand. It's not just what the agents are going to put in, it's what you can work with, that you're familiar with. And this is where eBPF, in my opinion, is going to shine this year. Basically saying, look, it doesn't matter if it's an AI that wrote this code, it doesn't matter if it's a person, if it's doing HTTP calls, I got you. You're going to see them, right? And this is a very cool use case for using eBPF if you're starting to write more and more code that is LLM generated. Now, at the same time, what about observing AI agents, right? So that's a whole new thing with observability. OTel just, not recently, but the spec for LLM observability and AI observability is changing rapidly as we kind of try and figure out what is needed in this world and what is interesting for people to kind of observe, essentially. And I think, at least my personal opinion on this take, is that traditional APM, so latency, errors, stuff like that, it's practically almost useless for LLM agents. So if you're writing an agent, right, and you're trying to see, to benchmark it, right, to see how it performs, then you don't care about latencies, right? It could be an hour-long transaction. It doesn't matter. I mean, it's just a user talking. And errors, you're not going to have errors. That's not how you should look at it. The only interesting part with LLMs is the internal logic. It's the decisions being made by the flows that you're writing. It's the tool calls. It's the chains that you're trying to measure. You're trying to make sense of whether or not the agent that you've developed is doing valid calls. Is it using the right tools? And these are things that I tend to believe will be covered by OpenTelemetry SDKs much better than eBPF could. I think you could there's a lot of things you could get from eBPF. You're going to see the calls to the models, right, to the providers. You're going to see the token usage. There's a lot you can see, but this is an area that I would spend time instrumenting correctly. And the frameworks are developing. And yeah, so I agree with the notion that you get so many spans on an LLM trace because it's basically an infinite call that is the same session. It's useless. I mean, it's not useless. It's just very difficult. It's posing. By the way, we see it on our platform as well. So if you used to have traces like with thousands of spans or a dozen of thousands of spans, then yeah, it's difficult. So in this area, I would focus on properly instrumenting it, and we see the common frameworks kind of pushing new instrumentations. They're kind of trying to follow suit with the new spec. It's a very exciting year for OTel and for AI in general. So just a closing note before we go into Q&A. There's quite a few ways to get started. OBI is the OpenTelemetry standard for eBPF-based tracing. It's amazing both as something to learn from and also something you can deploy, of course, and kind of see it working. It has a lot of work being done this year to make it more, to cover more stuff, to make it more production ready, a bunch of stuff that are very exciting this year. There's groundcover, which is ground cover, not ground, but no, I'm just joking. And I'm not going to talk about it too much. Just say that we have our eBPF tracing that we've been doing for a few years now. We have a lot of success with it, and it's also a way to start kind of seeing what you can get with the powers of eBPF. And of course, OpenTelemetry.io, which is just a general way of saying there's so much stuff you can do with OpenTelemetry, with SDKs, and you should use both of them together, as just mentioned. And it's very easy to try it out. eBPF is deployed within a few minutes. This is one of the cool parts about it. Yeah. So thank you for listening. And I think let's go to Q&A.
Awesome. Thank you, Aviv. This was great.
Yeah, thank you. There was some lively conversations that kind of took off on their own about events and logs. But before I get into that, if we have time, there are actually some questions. And actually, we have another special guest we would love to bring on, Nicola, who works on the OpenTelemetry
eBPF.
eBPF instrumentation.
Yeah, it's a mouthful. Yeah, what can I do? Like,
I got you, Reese. I got you.
First thing I blinked, I was like, OBI, what's the B for?
Well, I have an explanation for that, because using the E of the eBPF was much harder to make an acronym for it. And we always thought that this would be like Obi-Wan Kenobi, and we'll have a logo with the lightsaber, and it's all nerd stuff.
I love that.
I love like these backstories about, how things get named, including suggestions for OpenTelemetry before OpenTelemetry was, chosen. But anyways, that's a different story.
Yeah.
Nicola, do you want to briefly introduce yourself and where you're calling from?
Oh, yeah, sure. Yeah, I'm Nicola Gruchevsky. I work at Grafana Labs, but primarily I work on OpenTelemetry, this project called OpenTelemetry eBPF Instrumentation, or OBI for short. I'm one of the maintainers of the project, and also a fanboy of eBPF, just like Aviv is. And we pretty much care about the same thing. So the conversation here might be biased unless you can push us away from it. So.
It's a challenge to all you listeners out there.
Yeah.
I love the eBPF love.
Yeah.
So, yes, there was, hold on, I got to get back through here a little bit. Okay, so there is a comment and question from Ramachandra. I've worked with traces in OTel and really liked the W3C context baggage to store span IDs and trace IDs at each point in your microservice. I believe that eBPF doesn't have context, so how is this limitation addressed? Structurally, how does the philosophy of eBPF differ than OTel? That's kind of, I guess, two different parts, so I'll leave that to the experts.
Yeah, I can take a first stab at it, and then we can see if Aviv has another opinion on it. But when you think about it, like the OTel applications start with some context, right? Initially, there is no context whatsoever, and then they have to make it. So in eBPF, same thing. When, as Aviv says, you're monitoring the protocol as the traffic is coming through the read-write on the kernel or send-receive, whatever. You track that, and the first transaction you notice that doesn't have context, you make one, the W3C context, and from then on it's propagated to the best attempt. Like, I'm 100% agree with Aviv. The SDKs are much better at propagating context than eBPF. We have some support for this in the OB project, but it's not ideal. Like, it doesn't work for all frameworks and all languages, but we're trying to be better at that. And then for applications that are OTel instrumented, the context is in the protocol, right? So if you're thinking HTTP, it will be in the HTTP header. So since we're monitoring the traffic, we can read that just like the SDKs would after the headers are parsed by the frameworks. So yeah. Aviv, I don't know if you have any other comments.
Yeah, I think Nicola, it's very interesting to see. So I've read the like I mentioned the plans for this year for OB, and it has a lot to do with supporting more frameworks and doing distributed tracing around more scenarios.
Yeah.
I mean, I'm hoping to see it work. Like it's a challenge. I remember. I think I heard. I'm not sure if it was you or someone else doing a talk on Java on instrumenting Java for and how difficult it is to get the JDK, to understand the JDK from eBPF perspective. And it's so. I think in terms of philosophy, and again, I think this is it depends on who you ask, but this is kind of what I was trying to convey in the talk, that I think there are use cases where you want to stick with the SDK, which is proven to work, it's proven to provide the value for distributed tracing, but at the same time, you should push eBPF as hard as you can, because it's the easiest technology I've seen, I think, in my lifetime, potentially, to set up. It's difficult to develop, but to set it up is incredibly fast.
I would agree with that. If you can continue with the SDK, you can deploy it and whatever, you should do that. eBPF is there when you can't. Like, it's a framework you're not supported. It's a programming language that it's not well supported, or it's older version. You have something legacy, or you don't have time to do it for every application you have in your system. Just cover everything, cover corners, right?
And I think the last point is actually very, very important, because the reality is that even though everyone wants to spend time doing instrumentation with SDKs or instrumentation, somehow you end up pushing it to the next sprint and next sprint and next sprint, and you could get it. You could get something, maybe even more than you think, with maybe a day of work to read, choose what you want, and deploy it, and that's it.
I think there was a request to elaborate about context propagation with traces in eBPF.
Yes, it's always doing that. I'll take a stab at this. Okay. Try to see if I can speak to it in generic terms and not get too deep into the technical weeds of what's going on and how it does it, how we do it. So we have support for Go programming language, which is kind of separate than everything else, because in Go, the binary is available. It's fairly standard. As a programming language, there's no standard library associated with it. Everything's built in Go. So we attach probes in the various aspects of the Go generated code, and then we either read what's on the buffers that are incoming or use BPF to write in these buffers. And since Go is standard with the Go routines, every async operation is implemented with Go routines. We're able to track the Go routines as they're handing off work from one to the other. This works in OB for both HTTP and gRPC, or HTTP2, which is the underlying protocol for gRPC. Now, every other language is a different story because for the other languages, we don't have this. And like Aviv mentioned, some programming languages like Java are really difficult to get right. It's just, or .NET. You simply don't see anything reasonable from the eBPF side. All the handoffs from one thread pool to the next are done with user space handoff on the Java heap or the .NET heap and so on. So it's kind of really hard to tell. So we try our best. Obi has a very generic Java agent that we kind of inject into the running process to be able to get a little bit more information communicated to the eBPF side. So it's not pure eBPF. For .NET, we found out that .NET runtime does it on its own if you supply an incoming trace parent. So we kind of attach one on the incoming request if it didn't exist, and they do the rest for us. Same for proxies like Apache or like Nginx, things like that. So it's sort of like a battle, like we try to do certain programming languages and frameworks that we know participate well in this. Yeah, it's not ideal. Same for Node.js. Node.js, we inject a tiny agent through the debug interface to help us with this kind of correlation. And yeah, project is open source. It's part of the OpenTelemetry. A lot of ongoing discussions and a lot of ongoing effort to make this better. So if you're interested in more on this, please, you're welcome. Join the OTel community SIG call or the Slack channel. It's a great place to start.
Aviv, do you have anything to add?
No, I think Nicola covered the challenges pretty correctly.
Awesome. Next question we had, using the approach of pushing eBPF as much as possible because it's easy. How do you suggest avoiding duplicate tracing from SDK usage? Who would like to take that on?
Yeah, I'll start. That's a good question. It's a real life challenge. I think it depends on what exactly you're trying to avoid. So first I'll start by, Nicola just mentioned that OB does this thing, Nicola, correct me if I'm wrong, where if it knows that, if it sees a request that is already part of a trace, let's say that you have an SDK instrumenting some parts of the trace, then it would pick up the same trace. So essentially, it wouldn't generate a distinct trace. It would help you where you don't have instrumentation. So that's a really cool feature that you can use to kind of have one trace from everything. But let's say that it's somewhere that you can't do that, right? So you might end up with duplicate spans from different sources, so potentially from the SDK and from eBPF. And I think the real question is that necessarily a problem? I think it depends on what exactly do you get from each one of those. And so eBPF for example, it depends on the implementation. I could, for example, ensure that with groundcover, we capture the payloads passed on the request, which you don't get with the OTel tracing most of the time. And this might be confusing if you look at a list, for example, but if you're investigating something and you kind of just want more information, then having duplicate spans might actually be fine. I think this gets even more interesting when you start pushing LLMs to like AI SREs, right, to investigate, because then it doesn't matter that they have two spans. I mean, they want more information, that's fine. But it is tricky. It is tricky to kind of make sure that you're not keeping too much data, but at the same time, how to utilize what you do have. Nicola, any thoughts on that as well?
Yeah, I agree with you. Yeah, we do one other thing in the OpenTelemetry project, which kind of helps in the situation where, let's say, you have one Kubernetes cluster, lots of applications in there, 2 are instrumented, 10 are not, and you want to throw in the eBPF side to just cover the rest. But now you're saying, oh, what about these 2 that I've already instrumented? You're going to duplicate my traces, and it's going to look like a mess, and so on. Now, it's provided that's OpenTelemetry that you've instrumented with. We do work around that problem by doing a very simple trick. So eBPF is there. It monitors all the traffic. So we can monitor and we can see that you're actually exporting traces from your application. So we see that call that you're making. We want traces to the OTel collector or another cloud endpoint or whatever it is. It's standard OTel. So if it's gRPC, we try to parse the gRPC as well or match by the port. And if we see that, we sort of disable tracing for that application from the eBPF side. So the OB project will just kind of notice it and say, okay, well, I started tracing you, but no, you're doing your own thing, so I'll stop. So it has to see that first call out to exporting traces from the application. As soon as it does that, it sort of leaves that application alone and skips the tracing. You can produce metrics. If you're not sending metrics yourself, it will still continue doing that. But for example, if you start exporting metrics too, then it will notice that and actually stop metrics as well. So it's sort of like a heuristic that works in the background that tries to mitigate some of this duplication. You can disable this feature if you want multiple or duplicate traces as well. Like Aviv says, some people actually have use for that because they're thinking, okay, well, maybe I didn't get all that I needed from the manual instrumentation. Maybe I'm missing a call, right? So having some duplicates, but the fact that you're fully covered with eBPF could actually be beneficial. Like Aviv said, it's kind of hard to hide from eBPF because it's monitoring everything, right?
I didn't know about that feature. It's very cool.
Yeah, it's very simple. Like we just track to see if they're making a call out to the standard OTLP endpoints. We say, okay, leave it alone.
It's cool.
Next question. I love eBPF, but adding eBPF probes for instrumentation, then for security, networking, I'm concerned on the pressure made on the kernel. How can we make sure we are not putting extra pressure on the system?
Yeah, who wants to take this? I can give you my 5 cents if you want it. All right, so yeah, anything you add as an instrumentation is going to add pressure. It's going to add overhead to your system. The question is the alternative any better? So your alternative is not knowing what's going on. So you're going blind. The other alternative is add manual instrumentation or SDK instrumentation. I think that's higher overhead. So adding extra probes to do observability with eBPF, I think might be less of the 2 evils, if you will, on this. And yeah, I'll shut up now and maybe let Aviv say what he thinks about this.
Yeah, I think, well, I agree with Nicola, but and also you're right. There's many use cases for eBPF, and if you end up doing all of them with eBPF, then you could worry about adding a lot of pressure. But at the same time, there are alternatives that are worse, even in terms of just the overhead. Like I would 100 times prefer to use eBPF over any kernel module that any vendor has for whatever detections they want to run on my endpoint. And I also think I haven't heard so far, and this technology has been in use for multiple years now by many products, of a case that was confirmed to bring down a system or do something that's impactful because of eBPF. I think this is just how good this technology is in the Linux kernel, and it's worth mentioning there are guardrails in the kernel itself to protect against malicious use of eBPF, in the sense that, well, not malicious, but for example, the programs are limited in the amount of time or instructions, more specifically, but time they can execute in the kernel. So you can't block operations, for example. It's mostly read-only, right? So again, it's not something that could affect most of the parts of the system. So it's a valid concern, but I feel safe to say that it's been validated so far as don't worry about it, even without the operational, that's me being optimistic.
Now, I've actually tested it. It takes about 10,000 probes to really start feeling the overhead of the eBPF probes being added to the system. So 10,000 is a lot.
10,000 is a lot. How did you measure it, by the way, the pressure?
I have this desktop machine. I'm trying to bring it down by creating random probes that touch like difficult parts. All difficult parts. Like it's touching stuff like file writes and reads that are just massive overhead.
It is worth mentioning there are probes that create more pressure than others, and it's up to the essentially to whoever is creating the programs to kind of responsibly make sure they're doing it right. Fair point.
I'm just trying to make sure we've gotten to all the questions
all the
here.
Questions.
I think there's one around. So it happens that the trace produced from AI agents end up with so many spans that it's difficult to get value out of it. How can we improve this to get valuable traces from AI agents?
I'll start, Nicola.
Go for it.
So if you're asking about eBPF, I think it's actually not going to be too many spans in the sense that it would be mostly the calls to LLM directly, which is, I think, not as bad. It's going to be a lot potentially, but should be relatively fine. If you're talking about OTel SDK and just generally tracking what's going on with agents, to be honest, I think the world is kind of asking the same question and asking what is valuable. Is it even valuable to see a trace in that sense, right? Because traces are basically meant for you to figure out the flow of an end-to-end operation. But for agents, I mean, it's mostly, there are tool calls, which are also interesting, but I think the core aspect is just the agent like communicating with the model and making decisions. So maybe what we want to do is kind of adopt a new way of looking at, which is like, it's more collapsed potentially. Like you want to start asking questions like relations between different calls. For example, was there a case where tool call A was executed and then it wasn't followed by tool call B? And this is not something that you would do with a trace. It's something that you would do with, I guess, a new form of investigation. And it's interesting to see where this is going to go. I will also say one note is that I've tried adding auto instrumentation to AI SDKs recently, and it's definitely worth checking what is being pushed there, because there's a lot of random stuff that you probably don't care about. Maybe you would leave it there if it was something else because transactions are short. But here specifically, yes, please sanitize what you're sending. It's going to be impactful.
Oh, question here, quick one: how to start learning eBPF? Any good resources to share?
I would say Liz Rice's book. It's free if you sign up as an email. I think last time I checked at the Cilium's website, I think they have a link. Maybe we should post it here later. I don't know if it's possible, but I find Liz Rice's book is a great place to start, and it's on the modern eBPF.
Yeah, 100%. I think also there's all sorts of utilities you can use to kind of bootstrap eBPF without having to do the whole setup. So it's like BPF trace, which you can just run and attach probes to something and see it working like right away. It's cool. It's fairly easy to see it working. There is some learning curve. You kind of like it gets steeper and then it gets better, I think, is the way I like to think about it.
Yeah, BPF trace is awesome. I love it. I mean, recently I wanted to trace live recalls, and the old trace doesn't work, and I just wrote like a script and like, I don't know, 10 lines of code of BPF trace, and it did exactly what I needed to do.
Nicole, did you try writing eBPF code with LLM, with agents?
I haven't. No. Is it any good? Does it work?
Yeah. Let's say the verifier does not approve. Unsurprisingly.
Yeah, unsurprisingly, yeah.
It might get there eventually, but yeah.
All right, we have time for one more question. The recent version of the collector 0.145, it seems that the profiling schema has changed. Could you share any details about it?
This is about the eBPF profiler. Yeah, breakages happen. I'm sorry about that. I don't know what else we can say. Specs change, schema changes from time to time. The community tries not to break things, but obviously things would break from time to time.
Fair enough. Fair enough. All right. Well, thank you.
We've got a QR code on
Yes.
the screen, just really quickly.
For
learning eBPF.
Liz Rice's book.
Yeah, I think it's a link to Liz's GitHub repo with the examples accompanying the O'Reilly book, and then there's a link to the O'Reilly book from there as well. So,
yeah,
for anyone who wants to check it out, please scan the QR code.
And if you would like to follow up on any conversations or learn more about eBPF, you can always come to the CNCF Slack. And I believe the channel is OTel-eBPF-instrumentation.
Yes.
Yes. And let me see if I can get a link to the channel up real quick. In the meantime,
Groundcover has something open as well, right? The Coretta repo.
Yeah.
It's a great resource as well.
Yeah. Yeah. Let's see if I can pull it up quickly. It's actually a very cool use case for learning because it's fairly simple. It has like 2 probes potentially, and again, it visualizes network on a map in Grafana. Basically, it's a very nice stack to kind of bootstrap your Kubernetes visibility. And yeah, it's really good learning stuff.
Yeah, it's really good for network monitoring, I would say.
Yeah.
Yes. So the eBPF SIG channel that you can find Nicola in, and I'm sure Aviv is probably popping in there as well. The QR code to that Slack channel is up on the screen. If you're not already a member of CNCF Slack, it's really easy to sign up. You just put in your email to where you want the invite to go. You sign in, and you have access to literally every OpenTelemetry SIG that exists.
Very true. Yeah, and if you're looking, if you Google CNCF Slack, there's it'll take you to a page called CNCF Slack Community Inviter, and so then, as Reese said, put in the email, send you the link to get started. So yes, and then as we wrap up, next week we have another live stream. Can't believe it, 3 weeks in a row, where Reese and I will be joined by Julia Morgado for our first live stream as community managers called What's Up, OTel, where we talk about new and exciting things going on in OTel. Also your opportunity to interact with us as community managers. So we hope to see you there. And as always, like if your friends weren't able to join today, please tell them that the recording for this is available on demand on our YouTube channel OTel-official. So you can find all previous recordings of all of our live streams there.
All right. Thank you so much, everybody, for coming. And thank you
Thank
to Henrik, our
you. Yeah,
professor,
thank you.
Nicola, Adriana, Aviv.
Bye.
Have a good day, everybody.
Bye.
Bye.